All right, so here's what we're going to do. We are going to talk about moving to the new spot. Let's put into practice those equations that we were practicing, but we're going to use them in a real-world situation. So we're going to give you guys examples of problems in which you need to create an equation, so therefore you could actually solve it. The stuff from last night was just translating expressions, kind of doing the baby step into actually what we're talking about today. So we're going to review a couple things about writing and solving real-world equations. So that's our objective today, is to write and solve real-world equations. So yesterday, with my voice kind of going bye-bye, this comes out of Module 4. Let me change that. So Module 4, still Lesson 1. So 4.1 is where we're at still. I actually played the video that I recorded with you, and it did echo. That was kind of the weird thing, it echoed a little bit. But it was pretty funny listening to the kids respond to the questions I was asking you, and they were responding as if I was asking them. So I think that's kind of an interesting quality that occurs when you're watching these videos, is that you kind of feel like you're sitting in the classroom again. And you can't, it's almost instinctive to just, oh, I got that answer. And I literally had somebody who had his hand raised to answer a question in one of the classes. I'm like, dude, it's going to get answered. Just hold on. It's coming. It's coming. So if you haven't checked them out, please do, because it's a good way to go. So let's kind of review what they were talking about. First and foremost, you need to read the problem. First and foremost, you need to read the problem. Okay? If you don't read it, and when I say read, I mean the entire thing. A lot of times what you guys have learned to do is just skim through, pick numbers, and maybe a keyword here and there, and then launch into it. And that's not always a really good line of attack. So you need to read the problem. Next, you want to create and I'm going to put it verbal, let's see how to say that. Yeah, I guess we could say verbal expression. Of the situation. Now, they're strongly encouraging you to actually write out the words in your verbal expression. And the verbal expression, now for us, we're going to turn it into an equation. So we're going to look for a keyword that's going to tell us to write equals. But we're going to pay attention to what am I being asked to do. And then we can write it out in words. Because once we have it down in words, then it's easier to translate it into math. Okay? So, just a little thought. What do you think is the word or the type of word that is most likely going to make you write equals? Do you think about problems? What do you see most often that says, okay, that's where my equals goes? Okay?
Equivalent.
Okay. I don't see that often, to be honest with you. Okay, I really don't see equivalent that much. Yeah, a lot of times it's just a verb, like is. Okay. You might see a word like total. So something that deals with finality, you know. Those are the kinds of words that are going to tell you equal. So we're going to look for those in addition today. Because yesterday we just focused in on operations, okay? So create this verbal expression of the situation. Look for words like is and total. Those are going to kind of help you out. Now, here's something I did notice. A lot of the questions assume you have a knowledge of working with percents. And what needs to be true when you work with a percent? What do you have to do with it when you write a percent value into any kind of equation or do any kind of math with it? Oh, finally, a hand. Yes, Maggie. Yeah, you got to convert it to something, and most of the time we just convert it to a decimal because it's a super simple conversion. You just move the decimal left twice because percent means divide by 100. So we actually can't calculate with a number written in its percent form. So keep that in mind. I think that showed up on one of the questions that was a 10% or something, and they wrote 0.10 in front of the variable, okay? So watch out for that. So then we create our verbal expression, and then you're going to write the equation, and I'm going to give you a reminder here. And this is why I've been asking you to do this. So again, we got a lot of stuff to go back and redo. Use dimensional analysis to help write the equation. Okay? So dimensional analysis, I'm looking at like the last problem we did. It cost $20 per hour, and we don't know the exact number of hours, and then we're going to add to it the cost of renting the queue. So my money, I need to have cost at the end of this expression plus cost for this expression, because I can only add cost with cost. I can't add cost with hours. It doesn't make sense. The labels have to be the same in order to add or subtract. Okay. So a couple other things to think about. Define your variable. So you're going to have to pick, remember the variable is simply going to hold the place of the unknown value, and that's what you're actually going to be solving for. So, but you got to give it meaning, so you got to tell the reader what that variable represents. And you need to not say a number unless that's what you're being asked to solve for. You need to be specific. The number of hours worked. The number of dog years. Okay, you need to be as specific as you can so that anyone can look at your equation and go, oh, I see what this equation's about, without reading the problem. Okay, so very important that you define your variable. So when I define my variable, it looks just like this. You could say dog years, like for that other example. You could say dog's life in years. So you can get more specific, okay? But that's what I mean by define. It's literally, here's my variable, and then equals, and this is what it represents, okay? So it's really important that we put that part in. And then, let's see, what else? Anything else I can think of about writing the equation? Here's a big, huge warning. Very, underline, 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 rare, when the equation is written with the variable isolated. It's very rare when I'm in an ever see an equation where it says y equals 10 plus 2. Okay? That is, I'm going to say 99.9% of the time, that will never occur. Honestly, in the green algebra book, one equation in the entire book that the translation for that word problem had the variable by itself. Every other equation had math being done to the unknown to get to an answer. It was one entire equation. So if you write me an equation and there's a variable all by itself and there's all these numbers on the other side, you've done something wrong. You haven't translated it. What you've started doing is solving it. Okay? So you have to be super cautious that when you translate, it is verbatim what they're telling you. And then you can start doing the math after it. Okay? All right. I think that, let me just talk a little bit about answers before we move on. So step 5, we're going to solve. And when we solve, we're just going to follow our process that we've been talking about, Jason and Josh. And your answer, when you solve, will look like an equations answer, right? It'll say x equals, and then it'll give you some sort of number. Now, the problem is, what did it ask you to solve for in the original problem? Did it ask you to solve for x, or did it ask you to solve for how many hours did they rent the rent the play pool if the total cost was $270? Okay, I'm just making that up, obviously. The question isn't answering x. The question is answering how many hours. So because the x is just there to hold the place so I can actually do math, the variable does not belong in the answer at all. Okay, solve. No variable allowed in the answer. The equations that we solved earlier all came with a variable in them. And so I had to give it back in my answer. This one, you're coming up with a variable, or they're telling you use this variable to represent what it is we're trying to solve. But we're not trying to solve for the variable, we're trying to solve for that item, okay? Now, the other thing you need to do is check the answer for reasonableness. Okay, I'm starting to write like Frankenstein, I'm afraid. And we kind of joked around about this the other day. You know, is it reasonable that the son is 2 years younger than the dad? No, that is not reasonable, okay? Is it reasonable that I asked you to find 2 consecutive even numbers and you came up with odds? No, that's not reasonable. Is it reasonable that I asked you for how many hours does it take to drive from here to Baja, and you say 3,421? No, that's not reasonable, okay? So you need to look at your answer and stop and ask that question. Does this answer even make sense? Does it make sense that I got a mixed number answer and they were asking me for somebody's age? Does it make sense that I got a decimal answer and I was supposed to name how many dogs? Okay, does that make sense? Okay. Yeah. Very traditional problem is, you know, you have school buses going on a field trip, X amount of students, and you have X amount of buses. And if they have a limitation as to how many students can be per bus, if you have that, if the limitation is there can only be 35 students on a bus, so you do the math and you work out that you're going to need 2.7 buses. Is it reasonable that you say the answer is 2.7 buses? No. No, because they're not going to be bringing a 3/4 size bus or a 2/3 size bus to get this last little group of kids on. So that's sometimes you have to round your answer for reasonableness. All right? So those are the kinds of things I'm talking about. Check answer for reasonableness. And then the other thing is you need to make sure that is the answer labeled properly.
Oh my God.
Somebody just snorted. A little pig snort over here. And so here's the one that is my biggest pet peeve, because I'm pretty sure most of you have been living in the United States your entire life, right? And I'm afraid I did see this on the quiz. Just because you read it that way is not how we write it here in the United States of America. So this is one of my big pet peeves. When we're talking about money, shh, the dollar sign does go in front. Now, there are some times when most of our labels that deal with measurement go in the back, right? But when we're dealing with money, we're capitalists, it goes in the front. Most foreign countries, their money label goes in the back. Okay, but we're the ones that put it smack dab in the front, because that's pretty much what we're all about here in the U.S. Money. Okay, money, money, money. All right, so let's do an example problem. All right. Leon paid $26 and, oops, that's 6, sorry. I have some issues when I write too close to this thing. $26.50 for a shirt with a sales tax of 6% included. But he doesn't remember, because he's a boy, right? The price without tax.
Wow.
What was the price of the shirt? Okay, for all my what if naysayers out there, he's home. He lost the receipt. There's no tag left on the shirt. So he can't ask anybody and he can't read the thing. He's got to calculate it out. So don't give me what ifs. Okay, smart Alex. Okay, so let's go with a verbal model. Shh. So, how would we figure out, what would the verbal model look like for this particular problem? Ian?
Oh yeah, I was stretching.
No?
Alright.
Do I need to call in a girl about a shopping question?
Yes. Yes.
Well, yeah,
Okay.
girls shop, so.
Shh, 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 shh.
Price of the shirt.
Okay? You got to start with something, and that should be the shirt.
Plus sales tax. I don't know.
Oh, that's exactly good.
Oh.
Now remember, this is an equation. Leon paid.
Equals the total price.
Okay, that's a fantastic verbal model. Okay? So let's go ahead and let's work on the written expression. Okay? Now remember, we're looking for how are we going to come up with this. Now the tricky part in this one is the sales tax one. How are we going to write the sales tax that he got on there? So first thing I need to do is come up with a variable. So let's P represent the price of the shirt. That way we can all write the same equation. So to translate price of shirt into our written equation, what are we going to write? Say again. Yeah, P represents the price of the shirt. And then we're going to add, let me change colors. We're going to add to that the sales price. So this is where you guys have to use some memory bank here. How do you figure out sales tax of a shirt that costs P and it's a 6% sales tax? Maggie?
You move the percent sign to decimal over to the left place.
Okay, and that would give you what? 6%
0.06.
would be 0.06. And what am I going to do with that 0.06? Am I just going to add 6 cents to the price of the shirt and bam, I've got the price, the total cost? No. What do I have to do with that percent in order to figure out the sales tax? Aiden.
Multiply them.
Multiply what? Sorry.
Oh, multiply the price of the shirt with the sales tax.
Very good. Because remember, it's 6% of the cost of the shirt. Okay? So 6% of the cost of the shirt. By the way, you just found another word that means multiply. Of. Not every time. Because that one would not be a multiplication. It wouldn't be 0.06 times cost times shirt. No, that doesn't make sense. But again, of is a word that we often use with place of multiplication. And then we have equals. And what was the total price of the shirt? Yeah. He paid $26.50. Okay? So let's think about what's something that we've talked about that might make this problem a little easier to solve. What's something that we could try to use that we talked about this week? Spencer?
You can combine like terms.
Okay. We could combine like terms. So I'm going to switch us over to the new screen. Everybody good on this one?
Yeah.
So third step would be to solve. Let's solve it. So our equation is P plus 0.06P equals 26.50. Now I agree we've got the same variable, so I could combine like terms. What's the coefficient of the first P? 1. So if I add 1P and 0.06P, how much do I have altogether? 1.06P. Okay? What would be my next step in solving this problem? Okay, Brian?
You would divide 1.06 on each side.
Oh, here, let me change colors. We're going to divide both sides by 1.06. So we get P equals, and then we have to do some math off to the side, which is no big deal. We just do it. So we have 26.50. We're going to divide it by 1.06. Move the decimal twice, move the decimal twice, bring it straight up. 106 goes into 265 twice, which would give me 212. And I get 53 left over. And then bring down a 0. 106 times 5 would give me, exactly what we need. So I would get P equals 25. Okay. Step 4, is it reasonable if I paid $26.50 for a shirt that the shirt could have cost 25 bucks? Yeah. It's close. So I would say, yeah, it's less, which is good. If it was more, I'd say we've done something wrong. So now we're going to analyze our answer. And so we're like, yeah, I feel that's reasonable. Now I got to write it properly. What am I going to write as my answer? Oh, everybody should be able to raise their hand and tell me this one. This is easy. Luke, what's going to be the answer to this problem? Yeah, it's going to be $25, or the price of the shirt is 25 bucks. So your homework's on the board.